Welcome to Study Loop.
So in this problem, we are given that we have to prepare a buffer of a pH 10.43, and we have to find the mass ratio of the base to acid, which is CH3 to NH over CH3 to NH2Cl. So this is the ratio of the dimethyl amine to dimethyl ammonium chloride. So we have to find the mass ratio of this base to acid that we need to form a buffer with a pH of 10.43. So uh, to find this ratio, first we have to find the Kb value, or we have to know the Kb value of the base here and the Kb value for this CH3 to NH, or the dimethylamine, is 5.4 times 10 to the power minus 4. So we have to, as we know that we have to use the Henderson-Hasselbalch equation ultimately to find the mass ratio. We have to know the Ka value for this mixture, and as we know that the from the Kb value, we can find the Ka value, as we know that Ka value is equal to Kw over Kb. So just putting this, and here we will have 1 times 10 to the power minus 14 over this Kb value, 5.4 times 10 to the power minus 4. And then if we just take the negative log of this K value, we will get the pK value, negative log of Ka. And if we do all this calculation, we will find the pK value here as 10.73. So this is the pK value for this reaction or the solution. Now we have to set up the Henderson-Hasselbalch equation, which is like this: pH is equal to pKa plus log of base concentration over the acid concentration. So here we now know the pH value, which we have to find out a solution or a buffer of the pH of 10.43. And you know the pK value, we have just calculated this as 10.73. And here we have the base concentration over acid concentration. Now if we solve this equation for the base to acid concentration ratio, we will get the base concentration over the acid concentration as 0.5. So this is the ratio of the concentration of our, as our base here was CH3 to NH, or dimethyl amine, over CH3 to NH2Cl, is if we just like this one also as a ratio, that will be 0.5 over 1. Now these two we can write as So as you know that the concentration is basically mass by molar mass. That means mass of this dimethylamine or CH3 NH2 over its molar mass, and then again in the bottom we will have the mass of this, that will be mass of CH3 NH2Cl over the molar mass of CH3 NH2Cl. So this will be equal to this ratio here again, and then if we just put the molar mass values of these two, we'll have the equation as mass of dimethylamine over its molar mass. So the molar mass of dimethylamine is 45.09 gram, and then again here we have mass of CH2 NH2Cl dimethylamine chloride over the molar mass of um, dimethyl ammonium chloride, which is 81.54 gram, and this is equal to our ratio, which is 0.5 over 1. And now if we just solve this equation, just as the ratio of mass to mass, we will have mass of CH3 to NH2 over CH3 to NH over CH3 to mass of CH3 to NH2Cl. We will get this as the value as 0.28 gram, or so since it's a ratio, will not have any unit here. So this will be the ratio of the dimethyl amine to the dimethyl ammonium chloride of the so this is the mass ratio of dimethylamine to dimethyl ammonium chloride to form a buffer solution of pH 10.43.